From the background, we are geographers, and we have dealt with data from mobile phones for years in our working group. And we are going to discuss about the wearable sensors for mobility statistics, and we're focusing on, as I already mentioned, on the data from mobile phones. So why would it be important to integrate these kind of data sets is that the migration and the mobility are both a great potential and challenge of the 21st century from the perspective of economics and societal aspects. The mobility as a phenomenon has changed. People and goods are moving differently than before. For example, products or goods are delivered using robots. And it is important to find different and new data sources besides the old or the more traditional ones to understand the context and the cause-effect relationships. So the wearable technology can be defined as accessories and clothing incorporating computer and advanced electronic technologies or technology that people wear with themselves. So the examples can be smart glasses, fitness bands, smart clothing, smart watch, and smartphone. There are different use cases. For example, the fitness bands or monitors can be or are used in health and sports. This kind of technology or sensors can be used for public safety, entertainment purposes, for remote control, or even in science. The question is with wearable technology and sensors is the adoption rate because for example, PricewaterhouseCoopers has done a survey or a study that, and they have brought out that this kind of technology or sensors are being used by more the younger generation or people that are more interested in these kind of topics, or they see the specific purpose of this kind of technology. So keeping the wearable commitment is an issue that should be addressed when discussing the user needs and the convenience of using this kind of technology. So the physical and functional attributes are very important to take into account. We see that mobile phones refer or fulfill some of these attributes quite well because mobile phones are multifunctional. You can use the mobile phone for calling, sending text messages, communicating, for entertainment, and all kind of, most probably all know. The technology itself is not invasive in a sense that it is not attached to the skin, but the invasiveness comes into question that the mobile phone senses through the sensors every kind of data. For example, besides the sensors incorporated into the technology of the mobile phones, for example, GPS, accelerometers, microphones, mobile phones also let to collect other phone data, for example, information as a byproduct of ICT services, for example, call detail records, app use data. And the wide and increasing use of mobile phones give the researchers and also for the statistics a very good sample of people. And the spatial and temporal resolution is, I would say, very good or good enough to calculate different statistics. And also the long-term perspective, since the adoption of a mobile phone in the society is really high and increasing. And also there's many use cases where the data has already been used for detecting mobility patterns, behavioral studies, social media use, etc. In the mobility lab of University of Tartu, we have focused mainly on the CDR data and data from mobile application called Mobility Log. And Anto, I will give the floor to him. We'll demonstrate some of the cases where we have used this data for population statistics, detecting central places and catchment areas for tourism statistics, and many more.
Thank you, Pilleriine. It's a common knowledge that if you are giving a presentation, please focus on one main topic, but I'm going to ignore it. So I will give you a lot of different examples how we are using passive mobile positioning data. Firstly, really shortly about the data.
Okay, yes.
It's called report and contains mainly three different columns, three different variables, location, time, and pseudonymized user ID. And we are collecting the data already since 2006. And that's the simple structure of the table. ID, anonymized ID of user. We don't know the exact person behind the number. Then timestamp beginning of phone call or when the message was sent. We only have data about your active phone usage when you are sending messages or calling. It's not much. We don't have at the moment access to the internet usage data. On average, it means we have 4 data points per person per day. It's not a very nice number, but per month it's already 120, and you can multiply it with other numbers, then you can see that per year it's more than 1,000. And if the data sample is 400 or 500,000, then there is a lot of data to study how people or society is behaving in space and in time. Spatial resolution, Estonia is again not big, not small country. The spatial resolution of antennas, that's the theoretical coverage areas of mobile network. More densely populated areas have more antennas, natural areas not so much. So the accuracy has some limits. It takes a lot of data processing and a lot of modeling. One of the key elements we are using is so-called anchor point model. If you're using your mobile phone always in one location, that's maybe your home, at evenings, weekends, and so on. But on working days, if you're using it in here, then it's probably your working place. And in similar way, we can identify other meaningful places or locations for you. And we get home anchor points, working place, and others. And after some additional data input and modeling, we can get whatever statistics we want. Actually, maybe it's too arrogant to say, but at the moment we are already in the phase that before that people were asking from us, what can you do with the data? Today I can ask what you want to know. So everything is visible from this kind of data set. Most simple way, the distribution of population. It's really, the models are very nice and they are working very, very well. Estonian case is that the population registry is really, really bad. 1/5 or 1/4 of home locations or addresses are wrongly registered. And nobody has good solution except us. mobile positioning. And I remember just for comparison that that's the initial accuracy, but with help of some additional data sets like distribution of housing or census data, we can model the population density or distribution very, very well. And if we know home location, we know work location, then it's very easy to start analyzing commuting patterns or whatever regular movement patterns. And this can be interesting already for many different parties, like how to plan transportation, public transportation, or how to organize maintenance of roads, or plan new highways or whatever. And of course, it's a matter of taste. Should we keep it in abstract form, or we even try to model the results on top of a real road network to get some estimates about regular movements in Estonia. Then when we filter out even more data and leave only the most important, keep only the most important movements, then we can start analyze already the spatial hierarchy of administrative system based on commuting. Where are the central places? Estonian capital is Tallinn, Tartu, university town where our lab is. And we can see so-called hinterlands or catchment areas, plus some urban functional areas or regions as well. Gray lines are the historical central places and hinterlands. Estonian administrative system hasn't changed too much during the last 100 years. But if we extend the time series, people tend to change the place where they live. We can study even migration. You had your home location in here, but suddenly a similar pattern appears in another place. So we can assume that you changed your home location. And in here we can see the internal migration in Estonia between counties. And we can see how Tallinn is sucking in all the people, and peripherization is quite a big problem. But analyzing of migration, it's like really big picture and long time period, but we can zoom in time very, very strongly, and we can focus only on one evening or 1 hour or 1 minute even. It depends what you want. This is the movement of people during one day, one Christmas Eve, year 2010, I think. And again, we can see some spatial relationships. Somewhere are the central places. We see some clustering. We can compare the results with average flows and so on and so on. Then we can zoom in from Estonia. We are living in conditions of Schengen visa space. We don't have any border crossing statistics. All the tourism statistics is missing. And but that, according to same data, we can analyze how Estonians are visiting foreign countries, or how some foreign visitors are moving in Estonia. Case of Latvian fishermen on Lake Peipsi. Every row is 1 year. Blue means every stripe is 1 day per year. Blue means it's cold. Red means it's getting warmer. And black stripes is the number of Latvian fishermen. So if it's getting cold, lake is covered with ice, Latvians will appear if it's getting warmer, ice melts, Latvians disappear. And we don't have any other better data source to describe this phenomena. They're not staying in hotels or anything, they just usually one-day visitors. We can even see some connections with climate change. Warm winter, no ice, no Latvians, no money for local community. They are still buying food and consuming some local services. Or we can start thinking completely different way. We don't have to think only about space and society. We may think about biology. For example, what are your daily rhythms, diurnal rhythms, or seasonal rhythms, or weekly rhythms? When are you active? We can compare different weekdays, different months, and so on. Or we can zoom into one person to reveal chronotypes or what are your time preferences. Okay, we don't know who are the persons, but we can see really different patterns in here. Every column is one weekday, it's Monday, here is Sunday, and midnight and another midnight. And more black means that more phone calls appear during this time of the day. And nighttime, it's light, people are sleeping, then they wake up 7 or 8 and they start to use mobile phones. But when we look more closely, we can see really big differences. Or we can study social networks. If we know the initiator of a phone call and receiver of phone call, we can study the social networks and communities. Or we have to remember that today all the mobile phones usually have also GPS sensors. So we can, currently this is not a part of this dataset, but another dataset collected with some special application, movement of people in Tartu. So completely different level, completely different horizon. We can study where people stop, where they move, what's the travel mode, and so on, study regularities and so on. But okay, we are part of smart mobility session in here, but I'm afraid I have to say you that your life is really boring. Most of the time you are not moving. 90% of time you are sitting in one place and you are not changing the location. And usually it's home or work and sometimes elsewhere as well. But to conclude my part, we have to be careful with this kind of statistics. We all are familiar with the concept of digital divide and social exclusion. And maybe it's just a reflection of a wealthy world. People who have the devices, mobile devices, they have more money, they call more, and in here we compared mobile positioning data and official tourism statistics, and for different countries, the model works really differently. In some cases, the fit is very good, but in some cases, it's not so good. And it correlates not very strongly, but still strong enough with GDP. So we have to be careful what kind of information we have, how to interpret it.
So for the last slide, we wanted to introduce you a project called Infotechnological Mobility Observatory. And the aim is to develop a data infrastructure that supports mobility studies, and it integrates different data sets, data obtained from mobile phones, as described right now, and other IT tools. Also, the project incorporates country-specific e-data, for example, censuses, registers, and databases, and also the contextual data and descriptions for example, environmental information, land use, and functions. We have there 3 universities included in the project, and also Statistics Estonia. And during this project, we try to develop the infrastructure, to develop the data sets, and also find the possibilities to link these data sets to understand mobility even better. So, thank you.